Hi, everyone, and welcome to BinarX Week 22, Preliminary Design Development, Week 3 of 4. So today we are going to talk about what you need to include in your presentations that you'll be giving at your Preliminary Design Review, or PDR day, here at Curtin University on December 2nd, 2024, so just before the summer holidays. So don't worry, it's a lot of things that we've covered in previous weeks of the program, and that you may have already done and just need to update. And there is some new stuff too, and yeah, there's some stuff from your mission concept review that you'll update and reuse. But I hope you all have a great school holiday break, first of all, after this. And in term 4, for BinarX, we're going to focus on your individual payload teams and support from the Binar Space Program team and support you to get everything ready for your PDR presentations. But well done on being almost at the end of your first year in the BinarX Student Payload Development Program. So the first thing I want to talk about is the BinarX Summer Holiday Program, which is going to run in January 2025. We have had some of the students from the BinarX program join us last year when we ran it for the first time. It's a 10-day intensive program here at Curtin University, so January 13th to 17th and 20th to 24th, 2025, where we do all the payload development stuff, but we do it in model rockets. So it's very, very condensed into the electronics and hardware development side of things. But we also have a lot of creativity, a lot of branding. You can scan that QR code if you want to register your interest. We haven't started opening the applications yet, but you can register your interest and say that you want to come and that you're interested. And if you put your parents, if your parents put their contact details in there, we'll send out the information when it's ready. So yeah, building payloads, putting them in model rockets, 3D designing and 3D printing our nose cones, designing circuits, doing the prototyping that you see there in the center photo with the same microcontrollers that we're going to be using next year. So that's the more advanced one that we built that we actually are going to fly in space. It's very similar. You'll learn hands-on soldering tutorials. Students built all this themselves in terms of those circuits and using some more sensors. So it's a really great opportunity to come and see the labs and see the vibration shaker testing that we do, the vibration testing and the thermal vacuum chamber testing. And then there's a lot of fun with team building and painting your rockets, painting the 3D prints that you've painted, doing the branding, all hands-on. So it's all stuff we've either been working on in BinarX or we're going to work on next year. So if you can't join us, don't stress. We will get through it, but it's just a really fun and exciting and condensed way to really level up and just get those extra skills and make some new friends and see what the other schools are up to. And then of course at the end we have a rocket flight and we get all the data from the sensors on board that you've put and you process the data and you'll put those on posters as well. And yeah, we have cameras on everything, so it's pretty fun. Here's a little video. So PDR, what is PDR? PDR stands for Preliminary Design Review, and it's a key milestone in space missions. So our MCR, or Mission Concept Review, was a milestone, and you can see there on that page, on that table from the NASA Systems Engineering Handbook, there are these key decision and design gates, they're called. So in project management, you have decision points or milestones or design gates that you need to meet before proceeding to the next stage, because you don't want to have to go back and redo things. So you really make sure that you've got all the things that you need to go to the next phase before you get out of the current phase. So it will evaluate your design and ensure it's going to meet your mission objectives before you move forward. And then you're going to present your work to review panels at Curtin University at the end of term 4 on December 2nd. And you're all getting really good at it because you did it here for Mission Concept Review Day. And you all did a great job. So I know it's going to be a really good opportunity to share how much more progress you've made. And it's great. We're really looking forward to it. And there's going to be members of the community. Everyone's so interested in hearing what you're doing and seeing your progress. So I really hope you're able to make it. If your teachers haven't received the calendar invite for December 2nd, please reach out and let me know, and I'll make sure we get you added to that, because I know you do have to plan quite far in advance for your excursions. And so how does the PDR relate to MCR? Well, you already completed your mission concept review, and then we're going to now in our PDR add more detailed information and update some of the things that you've already completed in your mission concept review. So what will we be presenting? So the list on the right is what we want you to include. And that big table on the left with all the stuff on it, that's the one from NASA's Systems Engineering Handbook. It's their Systems Engineering Project Maturity Table. So whilst we're not going to get you to do every element from this with your payload, but know that what we are requesting from you is actually based on this table from a real space mission, because you're doing a real space mission, but one that's been around for a long time. And there's a couple of terms we'll familiarize you as well. So if something's preliminary versus something being baseline, if you zoom in there, you can see that some things are saying, oh, you need it to be preliminary and baseline. Preliminary is just early ideas that are still being refined. And baseline, or project baseline, it's a good term. You'll encounter it lots if you do more project stuff as you go through your careers and you end up being project managers. It's when you've finalized requirements or like locked them in that are unlikely to change, because you don't want to completely reinvent what you're doing, because there's a huge, if we're in industry, there's a time cost. It's all resources. So there's the sort of three things, which can be the quality, the time, and the cost. So it's like your budget, how long it's going to take you, and then how good your outcome is going to be. So those are things that you need to consider, and that's why baselines are important, because it kind of controls things from getting out of hand and making too much work for you and stressing you all out. So where update is written, you would just update these areas with any new information, but it doesn't mean change completely. Once a baseline has been established for something, varying too largely from that baseline can pull your project off track. So we'll go through the list on the right. So the first thing is your objective, your mission objective, which you had in your mission concept review. You're just going to update it. You may have slightly different wording, or you may have shifted the focus slightly, but it should look very similar to the one in your MCR. Second item is the success criteria, also updated from your MCR. So that is, we're going to introduce some terms: minimum success, full success, and extra success. Which is something you would hear or read if you flip through the Systems Engineering Handbook from NASA, and I'll go into that in more detail on a subsequent slide. Where you're going to have your block diagram in there. So that was BinarX week 16, where we did a block diagram of your payload, which was that simple flow chart. Number 4, revised requirements. So week 15, if you don't have it, there's an Excel spreadsheet in there with the requirements for what your payload needs to do. And again, if you need a refresher, you can go back to weeks 15 and 16 and rewatch those, so you know what you need to do. Item 5, a software flowchart. Don't worry, it's not as technical as it sounds. We'll get into that in a minute. Number 6, a parts list with a manufacturer names and part numbers and photos of the components. Not every last little bit, probably just the main 3 or 4 items for now, and photos of those parts. And it's just going to help you keep track of where you need to order everything from, or you can hand it off to your procurement person, or us actually, because we'll be procuring it for you, and send them through to us so we can buy stuff. Item 7, a timeline or project schedule. So we'll do that in something called a Gantt chart, and that's going to it's basically you planning the schedule of your work, and knowing what your deadlines are and putting those in so that you can make sure that you plan your work out accordingly. So it's like, just planning a project. You've all done it with group work, I'm sure, so you'll be better at this than a lot of us, I'm sure. Number 8 is a descoping plan. So if it looks like you're going to miss a deadline to have things ready to go for space because you're all doing really ambitious things, what's the plan for reducing the scope of the project so you get to fly something and still meet that minimum success, which we'll talk about in that slide in a few slides time. So yes, success criteria: minimum success, full success, extra success. Within that, you should have a couple of options for sort of scaling things back if you need to. If you don't have as many resources in terms of people are away or sick, or another project gets in the way, you still want to fly something, because flying something is going to be awesome, and talking to it and getting your data back. So we really want you to make sure that we support you. And this is actually something you do in a space mission. It's right in the space mission, because sometimes people change or budgets change, and they need to still be able to have a successful result of their mission, even if it is at a reduced scope or less work. All right, so PDR, objective and success criteria, you're going to update these from your MCR presentations. So your objective, what are you trying to achieve and why? So what's your mission's goal? So again, you should have had your baseline locked in after mission concept review, more or less, and then you're just going to sort of maybe refine it a little bit. You'll have your success criteria. We called that your key outcomes on your mission concept review. So what your minimum success was. So what would be like the minimum result that you could hope for that you'd be happy with? Full success. What is it exactly that you want to do? And what does that look like? And then extra success is like, oh, well, we really nailed that, and we can now add an extra component or have our stretch goals. So what other things would we want to do above and beyond? But they're not something that you necessarily need to do unless you've got that extra time and scope at the end. Oh, and I didn't mention in the list your key stakeholders, which you can update from your mission concept review presentations in terms of who's it for. Have you discovered that there might be more people interested in what you're doing in terms of stakeholders, or different groups, or someone that you thought would be interested in outcome maybe isn't as much anymore? You can update that and from your mission concept review and just have that in there so we can refresh us on who you're doing it for. And that might be yourselves as well. So if we go to BinarX week 15, a lot of you, I've got these either as hard copies or your teachers have sent them through, so well done and thank you. If you haven't gotten to these yet, please grab the Excel spreadsheet, and it's a list of what your payload needs to do to achieve its mission objectives. So if you've already started this, you can update any changes with any changes from what you've learned in the last few weeks or feedback from your mission concept review. And if you haven't started it, just we'll work on it in term 4, but it's really important that you have these requirements because the design side of things really needs to be done, and that's why it's a design review, is that we're really drilling down into your design a lot further at the end of term 4 and making sure that we're gonna fly the right thing. We're gonna make it and then fly. So blocks diagrams from BinarX week 16. And again, if you need a refresher on weeks 15 or 16, just jump back into those video lectures and you can watch me at double speed if you think you can handle that. And just rush, you don't have to spend ages on it, but just get a little refresher if you're rusty on any of this. So the block diagram is a simplified visual showing the main components of your payload and how they connect. So update it from what we may have worked on in week 16 and make sure it's clear and shows all critical components. Or if you're happy with it as it is, for those of you who have sent it through, that's fine, and we'll chat about it when we see you next. The software flowchart, again, don't get too bogged down if you're not sure about the coding. It's not coding, it's just how your code works. So it's a diagram showing the logical flow of your payload structure or coding structure, and you've probably seen these ones similar, they're all over the internet. Should I have a snack? Should I buy more Lego? It's like, do you have money? Yes. And then the decision is buy more Lego. So why is it important? It's going to explain how your payload's going to operate once it's launched. So there are actually specific set symbols. Those shapes aren't just random. And there's lots of different symbols that can be used. And I've included a link to lots of different ones in this week's lesson plan. But there are 4 main ones that you'll probably need. Not too many more. These will be the 4 that you'll really only use most likely, but if you do need extra ones, just have a look through that link and see what they are. But in most cases, you'll have the process symbol, which is the rectangle, and it represents a step in a process. It's the most common component of a flow chart. So, it would be like payload runs for X amount of time. Terminal symbol, it's the little, the start and the end, so it's the rounded rectangle. It indicates the beginning or end of a flowchart and usually has this text start or end on it. The next thing are the flow lines, so the arrows that go, and it's labeled there on the diagram, basically just connects the 2 blocks. They can be straight lines, they can be an arrow in one direction, they can be an arrow like both-sided arrows, just represents the different kinds of connections between the steps. And again, we're not going to finish all this today. This is just the stuff we're going to work on in term 4. Your decision symbol, which you can see there is the blue diamond, it indicates a step that decides the next step in a process. So it's usually a yes, no, true, false question. So you can just think about that, and this will help you with your code because when you go to write the code, you remember it's like if this equals that, then do this. It's yes, it's computational thinking at this point. Your parts list. So what should be included on your parts list? 3 or 4 key components of your payload. We will eventually need all the bits and pieces, but the main components are a good place to start. So your sensors, your microcontrollers that you're going to use. Now you can do this for your prototype, or you can do this for your final one. We'll work with you on it through term 4. So what you want to, there's a template for this in this week's resources. It's an Excel spreadsheet to get you started, so you can use that. You don't have to set one up. Put your team name on there, and then the description of the part is the first column, manufacturer's part number. So you want to find the part number. It makes it a lot easier to find and make sure you get the correct component and that you're designing for the correct component, because there's lots of very similar product numbers. Who makes it, so the manufacturer, how many you're going to order, how much they cost each, and a link to where we can buy them. So that's the supplier link. It's also helpful to include a little image, just a very small one at the end, so that you know what it looks like. It just makes it a lot easier to put together and to keep track of things when you're building and ordering. So yes, some of you have started these parts list already. If you're happy to adapt that into this template, it's quite a nice one, and then we'll have them all looking nice and schmick. But if you want to do something slightly different, you can as well in terms of how it looks. But I've just started this one for you. So your project timeline, we want to see how you're planning to map out your work for actually term 1 of next year. So you can use this template that I have put in the resources folder this week to plan out your work for the next term, if you find it helpful. But you won't present that at PDR. You present your forward timeline, or what we're going to do for next year. So don't worry about all the stuff that's on here. This is just a nice template that I've found online. That is kind of automated, so you can put in what the task is. That's called a work breakdown structure on the left-hand side, and that's great because if you break tasks down into chunks and in order, and then you can say who's doing it. You can put in how much you think is finished, when you're going to start, and when you're going to finish, and that should, if you start playing around with that, map it out on that timeline that you see. That you can change the dates. So for us, we'll say the beginning of term 1 2025 to say let's plan out to the end of term 1, like maybe just start planning out the first term, and then you'll be able to see that, and it gives everyone something to refer back to, and it's called a Gantt chart. So it's a type of bar chart that shows the project schedule, including tasks, deadlines, and milestones. So a task is something to be done. The deadline is when it needs to be done by, and then the milestones would be things like, in this case, we're doing PDR as a milestone. Our next milestone, I believe, will be CDR, but I'll get back to you on that. See if you can find out. So we'll communicate some of those deadlines and timelines to you in term 4 so that you can add them. So again, we're not going to have this all today. We're going to work on it through term 4, but this is going to help manage your time effectively and ensure all tasks are completed on schedule for the payload to be ready for spaceflight. And this will help you again with that descoping plan that we'll talk about, because if you're not meeting deadlines or you're falling behind, then you enact your descoping plan. So a descoping plan is a backup plan for you to reduce the scope of your project or your payload, or like you can scale it down a little bit so that you can't meet all the deadlines. And it's important because it's going to allow you to focus on essential parts of the mission to ensure you've got something ready to fly, even if it's not your full original design, because we understand everyone's got lots of commitments and everyone's busy. So you want to make sure you've got just different contingencies or different options to fly something and get a successful result. And you could even have unforeseen challenges arise. You could have delays, you could have people get sick. Someone changes schools and you don't have as many people. You still want your teams to achieve a minimum level of mission success. So for your payload project, a descoping plan might help you to continue to achieve important goals, even if you do encounter some problems and some stumbling blocks, or something breaks or doesn't go as expected. So yes, the maintain minimum success. If you kind of want to start one spot, you want to say, okay, what's our minimum success criteria, and then start there and build from that. But you wouldn't want to go any lower than that, because minimum success, and then you haven't gotten what you want out of the project. But be realistic, because you don't want to add too much stress. So you're getting a pretty good idea of how you're going so far, and we're going to support you through term 4. A lot more sort of hands-on and focused specific support for your payload. So that we can now take everything we've learned and crammed into our brains over the last 3 terms and apply it to our payloads. And last but certainly not least is a prototype, mock-up, and a poster. Prototype or mock-up and a poster of your payload. So whether you've got a working payload prototype on a breadboard with the Arduinos, or you've done a 3D printed model of it, or you've done something that conceptually represents it, that's a little bit more off the shelf that you're going to then use to base your design on, any of that would be beautiful to see. And we'd really love to see it in an A1 size poster as well, because we're going to have the engineering pavilion lobby up for after we do our reviews. You'll all stand with your models and your prototypes and your posters, and you can see what each other are doing. You'll have members of the Curtin team, the Binar Space Program team, and other members of the community coming and having a look. If you've ever done any other exhibition, engineering competitions or science fairs, kind of similar format, but it's also going to help you communicate your work, and you get to be creative here as well if you want to do something beautiful. I know one of our teams is talking about doing an art installation. I can see that there's a lot of creatives there as well. You're going to get the 3D printer out. If you don't have a 3D printer at your school, you can send us files. We have 3D printers. So this will all be the fun stuff that we're going to make for term 4 towards the end of towards PDR, and then PDR wraps up at the end of term 4. So that's it for term 3 of BinarX. So after we come back from school holidays, and again, have a great and restful break, work on any of the weeks you need to catch up on, or haven't started, and start working on or updating the things that we talked about today. So if you're stuck, again, or you want to just share your progress with us, please, we'd love to see what you're up to. And we're going to send out the schedule and come see you starting in, I think, week 2 of term 4 will be our first visit out. Yeah, if you're stuck or you just need to get in touch, binarx@curtin.edu.au so we can support you. But yeah, thank you so much for everyone's hard work, and we'll see you in term 4.